looked at over there, and we don't really do very much. And there's mechanistic detail covered in 191, and also the idea of multiple reaction sites in the same molecule. We really wouldn't cover that at all. So we were looking at very simple molecules, one reaction site, one functional group that does this. So whereas in 191 there's lots and lots more detail. And again, the same, this idea of isomerism and what it means. Like we would introduce optical isomerism, so the students will know what they are. But the idea that you flip when you do those substitutions, they would have no idea. We don't name them. We just say, look, they're different. They're mirror images of each other. We don't give them separate names. So there's a whole lot of new stuff in there, and that really isn't even talked about at level 3, but is covered in quite depth at 191. Okay, sorry. Oh, I just couldn't resist. I found your photo, so I thought, see, no, you talk kinetics. I'm like, oh, it's hoping you'd be here. It's always nice to get somebody. Again, level 2, we say these are the factors that affect rate. I think this year, level 2, I stretched it out. I made level 2 kinetics take a long time. I did a whole 2 periods on it. And that's it. That's all the kinetics they've done. So to come in and look at all this again, all the maths that's involved in this, is a huge leap forward. So I think for those of you that teach 191, anyway, assume they've done no maths, and assume for kinetics that they've done no kinetics. I think it's safer. The exams. The other thing too is the exam formula. I've got a couple of. I went through the 2007 level 3 and the 2007 191 paper, and I thought, where's the overlap? I only looked at the long answer. I thought multi-choice is just going to take me too long. There was 37 marks in 191 out of the 60 that a level 3 student probably wouldn't even recognise the question. So there was absolutely no overlap at all. So there is a huge leap. That's a lot more when you think that leaves 23 marks that they have done. But again, I've got some examples here, and if we look at the level of question and how the questions are worded, it's a big leap. You know, I mean, you guys can all read. I don't need to read it to you, but it is a huge difference. I'll just give you 30 seconds. And I guess what you're noticing is how much this side here, which is the level 3, holds your hands through the problem, and how much this says, here's the question, answer it. The mark distribution is kind of interesting too. The idea of the fact that these kids are going for marks and percentages is, I mean, they've just had 3 years of achieving merit excellence. And what that means and how that means in terms of understanding how you approach an exam is really different. And I think that, I mean, when I started with my joke, and there's kind of a sadness amongst that as well. And I mean, which one's better? We could have an argument forever. Most of us would probably be on one side. But it's hugely different. Again, just another one. That one. That's the maths one, I guess. And if you look at the maths involved in the 2 papers. I think one of the interesting things about the maths is that if when you write up like the equilibrium constant expression, the first time you write it up, kids don't understand k as a number. They don't understand that a constant's actually a number. You know, they think of it as another, because it's a letter, it's got to be another variable. And so there's that huge confusion about that. It's that whole thinking that we assume, because we've known it forever. I mean, I don't remember a time when I didn't understand that, but I'll bet you there was. And it's just, yes, maybe it's how old I am. But it is like, for that idea, that whole idea that K, a letter, can be a number as well. Like, it represents a real number, an actual unchanging number. And we introduce it with a letter. And they've just done 3 or 4 years of maths that says letters represent changing numbers. And then we come along as chemistry teachers and put K equals, and more letters that are variables, but this one here isn't. It's a number, it's a constant. And that's confusing.
That's why you should use
Again, another example, and again the detail and the level is so different. They're asking the same stuff in a lot of cases, but the level and the detail and the maths that is required. Oh, yeah, this is, I just threw this one on there. This was, again, in the 2007 paper. I challenge anybody to answer the last part of it. That was in the paper. That's how good MCA really is. Yeah.
So chemists didn't write it?
Oh, I don't believe it. A chemistry teacher did, yeah. I'm not sure if he was a chemist or he or she was a chemist or not.
Yeah, but they reviewed it.
Yeah. It's the good news is, and I've got to throw this in because it's one of my pet frustrations. The good news is when the marking schedule it said the answer to that question won't be counted. But how many? What does the question like that do? It actually throws the bright kids because they go, I think I understand this stuff, and they get a question like that, and I don't get it. Don't understand. So that was about the middle of the paper. So now they've got the rest of the second half of the paper going, I thought I knew stuff and I don't really. And panicking and worrying about it. And NZQA just thinks that they can solve that by saying, I mean, there's a total paranoia about the fact that somebody might see the exams the day before or something. So they hide it all away, knowing it's set. And so the proofreading and the checking process is because of that, suspect. And we end up with things like that. And every year, there'll be a mistake somewhere in one of the science papers in NCA. And that's one of the furthest that came out of 2007 chemistry. It's just, it's a bit scary, really. I mean, the obvious answer only is 0. That's not what I meant. So if you answered it the way they meant it, do you pass? Or okay, that's